Hi folks, so this is the turning points and points of inflection. So we're going to use calculus now to figure out on a graph where the graph will turn and also the point of inflection. So I'll get to that in a minute. So if you take any graph and if you take any function for f of x, so if you look at the example down here, so it says y is equal to x cubed minus 9x squared plus 15x. So that's just an example, but you could have any. So we're going to be kind of focusing on cubics here a little bit. So if there was a cubic like this on a graph, so it could be anywhere, but if it was like that, so we already know, so what you'll have done so far is that you'll have found, by differentiating, it finds the slope of the tangent of any tangent on the curve. So it gives you something for a tangent there, or a tangent there, or a tangent there, or a tangent there on a graph. So what we'll be focusing on now is turning points. So you can see that turning point is there and another turning point is here. So those are called local max and local mins. So that there is a local max because it's the max, and then this is a local min. So how do we find those points then from using differentiation? So what you should be able to see is that there's going to be a tangent to those points like that, and what you should be able to see is that they're a straight line, or that they always have to be a straight line, because they touch the point, they touch the graph at one place and they're going through that point on the max, and the other one is the min. So right, so have a think about then what differentiation is. So the reason we differentiate is that it gives you the slope of the tangent. So the slope, so think about those lines that I've drawn, those horizontal lines. What would the slope of them have to be? So you should be able to see that they're going to be 0. So the slope of that line, of those two lines I've drawn, will have to be 0 in both cases. So therefore dy dx has to be 0 at both of these. So we can use that information then, because we know dy dx has to be 0. We can use that to figure out the points. So differentiation is going to be used here anyway. We can see that straight away. Now look down at the rules here. So if dy dx is equal to 0 and d2y dx squared is less than 0, is negative at a point, then the local point is then that means that it's local maximum. Y dx equals 0 and d2y dx squared is greater than 0, well then it's going to be a local minimum. So that's just going to help us figure out which one will be the min. So let's have a look through the example anyway. So we have to find dy dx anyway, and we'll take it from there then. So dy dx would be 3x squared minus 18x plus 15. So that would be dy dx. So I'm going to let that then be equal to 0. So 3x squared minus 18x plus 15 is equal to 0, because I know that at a max or a min, dy dx will be 0. So I'm going to let it equal to 0. And then I'm going to solve for x, and that should help us find the points then. Now for this one in particular, I can divide across by 3 here just to make the quadratic a little bit simpler. So let's factorize it. Okay, so we're going to get x is equal to 5 or x is equal to 1. So there are two values for x then. So those give us the x values of the points of the max and mins, but we have to put it back in. So we're going to put it back into the original one then, because those points are on that curve. So let's just put them both back in. So if x equals 5, then y will equal 5 cubed minus 9 times 5 squared plus 15 times 5. So that's putting in 5 And then so we can go, you can just put that into the calculator, then it'll give you the answer. I'll just put the other one in here as well. So if x is equal to 1, well then y equals 1 cubed minus 9 times 1 squared plus 15 times 1. Right, so if you put those in the calculator, then for the first one you'll get minus 25, and the second one you'll get 7. So those are my y values then. So I found out that the max and the min here are 5 minus 25 and 1, 7. So those are the max and mins. Right, so you found them, but the problem left is that we actually don't know which one is the max and which one is the min. So, and you could go to the graph and try and draw, and you'd be able to figure it out if you're able to draw a cubic. But you have to be able to decide from this, so that's where the second part comes in. So now if d2y dx squared is less than 0, well then that's going to be the max. And if d2y dx squared is greater than 0, that will be the min. So that's how we're going to decide then. So I'm going to find d2y dx squared. So that's just the second derivative of it. So I know dy dx is that thing there. So d2y dx, I'm just differentiating that again. So I get 6x minus 18. And now I'm going to put in my values. So I'm going to put in my 5 here, and I'm going to put in my 1 and see if I get something less than 0 or greater than 0. So first one, 6 times 5 minus 18 would give me 30, take away 18, so that would be 12, so that's greater than 0. So 12 is greater than 0. And then if I put in a 1, so 6x minus 18, I just put in a 1, I get 6 times 1, take away 18, so I get minus 12, so that is less than 0 then. So yeah, so d2y dx squared, so the less than 0 one, that will be the max. So therefore this is the max then. And then this one has to be the min. So that's where it's greater than 0. So I'm just putting in the value of x from the point. So I found my max and my min for the graph then, from differentiation. So I'm going to just try yeah, so we won't do point of inflection here. So if you want to just try that, if you want to try to do the same thing, just find the max and the min for that cubic, and then you can play it on and I'll go to the answer. Right, so let's just differentiate it anyway. So that's always going to be the first thing we have to do. So we get 3x squared minus 12x plus 9, and then the 2 will be gone when you differentiate it. So I'm going to let that be equal to 0 then. So let's just solve it. So I can divide across by 3 here. So x squared minus 4x plus 3 is equal to 0. So we get x minus 3, x minus 1 is equal to 0. So x is equal to 3 or x is equal to 1. So those are my x values. So I'm going to, it's always the original then that you put it back into. So I'll put it back into this now, and that will give me my y values. So y is equal to 3 cubed minus 6 times 3 squared plus 9 times 3 plus 2 is equal to. So we should just get 2 there, and then put a 1 in, so y equals 1 cubed minus 6 times 1 squared plus 9 times 1 plus 2. So we should get 6 there. So I figured out my x and y values for each then, so I'm getting 3, 2, and I'm getting 1, 6. So those are my max and mins. The last thing then is just to figure out which one is the max, which one is the min. So let's get d2y dx squared. That'll help us figure out. So d2y dx squared, so dy dx is this, so therefore it will be 6x minus 12. So let's just sub in a 3 then in for the x, so 6 times 3 minus 12 will be 18 minus 12, which is 6, so 6 is greater than 0. And let's put in a 1 now, so 6 times 1 minus 12, that gives me minus 6, so that's less than 0 obviously. So this one here has to be the max, and this one here has to be the min. And that's it then, we're done.